Hello everyone. So today we're going to be covering 1-1 solving linear equations and 1-2 solving linear inequalities. Okay, those are the two things we're going through. So you may have looked at your note sheet and noticed these questions. So what we're going to do first, I'm going to cover some information on those questions, and then you're going to try to figure out those questions, and then we'll see if you're correct or not. Okay? So some things we have to cover a little bit. What are the subsets of real numbers? Okay? So this whole thing here is a diagram that's going to cover real numbers. Okay? So the first two, we're going to talk about the largest two sets are going to be the irrational numbers and rational numbers. Okay? Irrational numbers, the way I remember it, might not be the nicest, but I think about irrational people. Irrational people are kind of crazy and you can't predict what they're going to do. All right? So an irrational number would be something like pi. Okay? Maybe you memorized pi to 52 decimal places or something like that, but there comes to a point where you don't know what the next number of pi is going to be. So you can't predict the decimal. It does not repeat. Okay? So a way to explain these would be non-terminating. Okay? They don't end. And non-repeating decimals. So, crazy numbers, crazy decimals, crazy people, irrational, all right? Maybe you want to list a couple more that might be irrational numbers. Some things you see would be square roots, like a square root of 3, okay? You can probably estimate that to 1 or 2 decimal places, but at some point you're going to have to whip out a calculator to get the rest of the decimals, all right? A number that you're going to see in Algebra 2 would be the number e. It's called Euler's number. It's kind of like pi. They're similar, okay? It's like 2.718, and then it goes blah, 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 on forever, okay? Kind of interesting FYI piece here. They use pi, digits of pi. They try to calculate that to as many as they possibly can, and they can use digits of pi in calculations to determine strength of supercomputers, okay? So, rational numbers are more like rational people, okay? We can predict them, all right? We know what it's going to be. The best way to write rational numbers would be anything that can be written as a fraction, okay? So, all fractions. And that's fractions that are following the rules of mathematics, okay? So if you got something like 2.03 divided by 1.765, okay, that might not be a rational number because that's not really a true fraction. We can't have decimals in fractions because those are fractions inside of fractions, which are called complex. Okay, complex fractions. So, these ones can be repeating decimals, anything that's written as a fraction, all right? So you run into something like this where it's like, oh, that goes on forever. That's a crazy number. It's irrational. Well, we know what it is. 0.3 repeating is just 1/3, okay? Anything that can be written as a fraction is a rational number. Positive, negatives, 0. We can technically write 0 as a fraction, 0 to 1, 0 over 1, excuse me. So you can write anything over 1 to make a fraction, okay? So those are the two biggest. Real contains both of them. So irrational does not have any subsets. Rational has 3 subsets, okay? The first subset of rational numbers would be the integers, okay? You've heard integers before. It's kind of a goofy word that you don't use on a daily basis, so hopefully it's stuck in your brain somewhere. Integers are going to be like negatives and positives that are really nice numbers, okay? They don't have any decimals. It's just negatives and positives. No decimals, includes zeros, okay? Maybe your brain's starting to pick up where we're going here, but the next subset of the rational numbers would be whole numbers, okay? Whole numbers would be numbers like 0, 1, 2, 3, and going on forever, okay? And then the smallest set of numbers that we're working with here would be called natural numbers. Natural numbers are pretty much the same thing as whole numbers, but they don't have the whole in it, all right? When I say that, I mean they don't have 0, okay? 0 kind of looks like a whole, so it's included in whole numbers. Natural does not have the whole, okay? So when we're looking at all these, they are all a part of each other. Natural is a part of wholes, whole is a part of integers, integers is a part of rationals, okay? And rationals is a part of real numbers, okay? So if I say integers is a part of naturals, or integers and naturals are the same thing, that's not true because integers has the negatives and 0 and naturals does not. So it's kind of like those things in geometry where you can say that all squares are rectangles, but all rectangles are not squares. Kind of something like that, okay? So they're all subsets of each other. So you've heard these in your last 3-4 math classes probably, all right? Next thing to look at before we go back to the bell ringer will be the properties of addition and multiplication. And these are ones that you should recognize as well. We're just going to kind of review them here quick. So we got commutative, associative, identity, inverse, and distributive property down here. So commutative property, that's when you just have something like A plus B is equal to B plus A. It doesn't matter how you add two things. You can switch them around. Addition is commutative, okay? If you want an example with numbers for something like this, if you did 3 plus 2, that's the same thing as 2 plus 3. You get 5 either way, okay? Multiplication version of that, you got A times B, or I don't need the parentheses, but we'll just do with it, okay, is equal to B times A. Same kind of idea. We'll use a 3 and a 2. 3 times 2 is equal to 2 times 3, so 6 equals 6, all right? Multiplication and addition are commutative. It means we can flip things around, all right? The point of going through these types of things, maybe, since we're going through them right here, is in solving equations. We use these when we solve equations. We could prove a solving of an equation using these steps, okay? Might not have to do that, but you should be able to kind of spit these rules out as we need them. So associative is often called the rule of grouping. Okay, so if you have A plus B plus C is equal to A plus B plus C. Okay, so associative, my brain says we got parentheses in there and we are associating the parentheses with the group. Okay, we're regrouping things. So I got B plus C grouped on the left, A plus B grouped on the right. Doesn't matter how we add them, we're going to get the same thing. Addition is commutative and we can associate things as well with addition. So similar multiplication, we got A times B times C, all right, and I got the BC grouped together. That's equal to A times B, group those together, times C, okay? And if you wanted to throw numbers in there for ABC, you can see that associative property does hold true 100% of the time, okay? Now, we don't have subtraction or division in here because subtraction will introduce negative numbers and those are not commutative, and division could also introduce negative things, or it could, like 2 divided by 3 is not the same thing as 3 divided by 2, okay? So reciprocals are not commutative. All right, so identity. What can you add to a number to get that number back out, all right? A plus 0 is going to get me A. So this would be the property of identity. If I add 0 to something, I'll get that number back out. Don't really use that a whole lot, but it's a property of a number, okay? Multiplicative identity, or identity of multiplication. What can I multiply by a number to get that number back out? That would be a 1. A times 1 equals A. And you actually use this a handful of times when you're using common denominators and stuff like that. We use a trick called the clever 1, where you multiply by a 1, which is actually like 2 over 2, okay? So inverse. Similar to identity, we're going to be adding something or multiplying by something depending on addition or multiplication, but we want to cancel stuff out. So what can I add to something to cancel it out? Well, A plus negative A, that equals 0. That cancels it out. We use this a ton when we're solving equations, right? You add an opposite to move things from one side of an equation to another, okay? Multiplicative inverse. Now, you might be thinking we're trying to cancel stuff out here again and make it a 0. Then you're like, well, multiply by 0, okay? Well, that's called a zero product property or a 0 property. That's not the inverse. So when you're looking to cancel things out using inverses, you think about reciprocals, okay? We're trying to cancel it to a 1. All right, those A's are going to cancel when we get a 1. Okay, so those are inverses of addition and inverses of multiplication. And then distributive property, we got A times quantity B plus C. That will equal A times B plus A times C. All right, that's the way you're going to see it in textbooks. When I write it, I like to do this to kind of show you that I'm multiplying that variable through that quantity. All right, so these are our number sets and these are our properties of numbers. Going back to the bell ringer, okay, Pause the video here, see if you can answer these 4 questions, give yourself a minute or 2, talk about it at your table, and then come back to see the solutions here. All right, so number 1, which set of numbers to which square root 81 belongs? All right, so you might be like automatically, square root, that's an irrational number. Well, no, is it a nice square root or not? This is actually just a 9, okay? Then you're asking yourself, what number set or sets does 9 belong to? Well, that's naturals, that's whole numbers, that's integers, that's rationals, and reals. Okay, it belongs to every single one of those number sets. It's a nice number, it's positive, we can make it a fraction, so that's included in all of those. Okay, 7/9. All right, so we have a fraction. So that should, I'm going to use number 1 to kind of get this answer, that should take out naturals, that'll take out wholes, that'll take out integers, because none of those include decimals or fractions. So that means we have only rationals and reals for that one. Okay, so 7/9 belongs to only rationals and reals. Number 3, what number property is shown here? You got A plus quantity 7 plus C is equal to A plus, or quantity A plus 7 plus C. We are grouping things. Okay, we're grouping that, we're grouping that. This is called associative property. And then we want to make sure we indicate the operation that we're doing here. Associative of addition. You can abbreviate these if you want to. Just be careful when you abbreviate associative. You might be writing something bad on your paper if you abbreviated that weird. Okay. Number 4, what's going on? Well, we got 3 times 4, 3 times 0.02 or 0.2. Ooh, there's a typo there. That should be 0.2, not 0.02. Okay. We are distributing that. So this is just distributive property. All right, and distributive is not an addition or multiplication. It's just a distributive property. Okay. And then for the sake of time, let's skip number 5. If you did that, I'm sorry. We're going to skip it. Okay. So on to the main part of the lesson. So on to solving equations and inequalities. Okay. So when we're solving equations or writing equations and inequalities, we have to understand how math turns into words and words turns into math. Okay? If you need to write some of these down, I know it's kind of fuzzy, kind of hard to see. I think it might be on your paper, but addition, some words that indicate addition would be adding, sum, increase, combine, together. Together's a big one. Subtraction, okay, words that indicate subtraction, obviously subtract. Decreased is subtraction, difference is subtraction, take away. Okay, multiplication, you got product, times, of is the big one. Okay, when you're talking about percentages, like 25% of something, you're going to multiply it by 0.25. Okay, and division, one that's used quite a bit, is quotient. Okay, that should be a word that's stuck in your brain. Ratio means division or simply divided by. And then equals, you're going to write is for equals. So if I say, if I'm reading something, x plus 2 equals 5, I could say 2 more than a number is equal to 5, something like that. Okay, so we're just going to practice a couple of these and then kind of move on to the next concept. Okay, some of them on the worksheet that you're going to get a little more complicated than these, but you should kind of have a good idea how to do it. All right, so A is one that kind of catches people sometimes. This is write an algebraic expression to represent the verbal expression 7 less than a number. Okay, people often just read this and write it out. So they're like 7 less than is a minus a number. Okay, so like 7 minus x, 7 less than a number. Well, in reality, that's not what we're looking for. Okay, this would be a number less than 7 or a number take away from 7. So that's incorrect. Okay, we have to think of 7 less than a number. That'd be a number minus 7. Okay, when you're writing these out, use actual numbers. Okay, 7 less than a number. If I'm thinking of a number like 15, I do 7 less than that, and that's 8. Okay, so you had to do 15 minus 7 to get the 8. All right, think about it logically before you write a statement down. For B, write an algebraic expression to represent the verbal expression the square of a number decreased by the product of 5 and the number. Okay, This one you can kind of read it and start writing it while you're reading it, all right? The square of a number, so x squared or n squared, whatever you want to use, is decreased by, so decreased by the product of 5 and the number, okay? Product means multiplying, square means an exponent, okay? Decreased by means minus. Those are the important words there, okay? That should make sense. And then C, 2 less than the cube of a number. So this is similar to A, okay? It's 2 less than a number, so the cube of a number, x cubed, 2 less. So x cubed minus 2, okay? So you're going the other direction here. You're writing a verbal sentence to represent this, okay? So go ahead and pause the video, write something out that you think makes sense with these, and then come back and I'll show you what I would write, okay? So for A, we got 6 equals negative 5 plus x, all right? If you want to write this all fancy-like, okay, you could say 6 is equal to the opposite, or the inverse of, I would say the opposite, of 5 added to a number. Okay? The nice thing about these, you can write it a million different ways. Well, I don't say a million, but you can write it a lot of different ways. Okay? You generally want to write it as this, the way this is written. You're not going to rearrange things or solve anything and then write a statement. You're just going to write a statement about how that's written. Okay? If you didn't want to write the opposite, you could have written negative 5. Okay? 6 is equal to, or you could have said 6 is equal to the sum of negative 5 and a number. All right? That would work as well. Okay? B, you could say or write the product of 7 and a number, or 2 less than the product of 7 and a number, is equal to 19. The product of 7 and a number minus 2 equals 19, just how it's written there. That works as well, okay? When you're writing a verbal sentence, you want to write the numbers out, like 6, I wrote S-I-X, 5, I wrote F-I-V-I, or F-I-V-I, F-I-V-E, okay? One that's a little bit tricky that you're going to see on your worksheet, say something like this. You might see something like this, okay? The way you would write something like this is you have to try to get something in your words to say that those are being added together first, okay? So the way this could be written is you could say 3 times the sum of a number and 2 is 4. Okay? So the thing that indicates the quantity here, it's the sum of a number and 2. So we're saying a number times a sum of something, or a number times a subtraction of something if we had a subtraction. Okay? So be careful with those ones. Okay. We got these 4 properties. You just kind of have to, we're just reviewing them. Oh my gosh. All right, we got these 4 properties of inequality. We don't use them a whole lot. We just kind of use them in solving equations and stuff like that. I don't make you prove anything. Okay, so just for the sake of seeing them, we have our reflexive property, symmetric property, transitive property, and substitution property. You saw these types of things in Algebra 1 and in geometry. They're probably more in your brain from geometry when you were working with proofs and stuff like that. All right? So, basic solving linear equations. We've done a handful of these. There's going to be some harder ones coming your way, and I'm going to show you a couple of them on the worksheet at the end of the video. All right? So, solve m minus 5.48 equals 0.02. Check your solution. All right? These are one-step equations. We should know how to solve these pretty quick. So we got to get the variable by itself, all right? So we got to add the 5.48 to both sides, okay? And guess what property we used to move that thing around? That's the inverse property of addition. That and that, those are inverses, okay? That's the point of doing the stuff that we did earlier. So we add those together, we get 5.5, Okay, 5.48 plus 0.02 is 5.5, and that is it. When it says check your solution, I know this should be fairly obvious. That means take your answer, plug it in, see if it works out. Okay? If I plug in my answer of 5.5, does it work out to give me a 0.02? Yes. If you followed your rules correctly here, it should always work out. You should always be able to check your solutions on basic solving equations, linear equations, stuff like that. Okay? B, 18 equals 1/2 times t. So again, we got to get that variable by itself. How are we going to do it? All right? Well, it's 1/2 times t. So you might be saying, well, I'm going to divide by a half on both sides. Okay? That might be your first thought. But if I'm dividing by a fraction, sometimes that can be kind of confusing. Fractions are not very nice to high school kids. All right? A better way, I want to use the multiplicative inverse of 1/2. Okay? So that means I'm going to multiply it by a reciprocal, which is 2 over 1, or just a 2. So if I multiply both sides by 2, that'll cancel out my 1/2, and I got 2 times 18, which is 36. So I got t equals 36. Okay? And again, we can check our solutions. If I'm looking at this, you should be able to kind of do this in your head. If I put a 36 in there, I would do 1/2 times 36, so half of 36 will be 18. All right. C, similar. So if you're working ahead, that's fine. I want to multiply by an inverse, or the multiplicative inverse, which would be the reciprocal, which is 3/2. So multiply the left side by 3/2, multiply the right side by 3/2, right? And then you got to remember how to multiply fractions. I would prefer that you try to do this stuff without a calculator. Okay? We got 10 times 3/2. How are we multiplying fractions? Well, we make both of them fractions, and the thing I've been getting from our middle school a little bit lately is that you just multiply straight across and you simplify later. That is fine. Okay, so you get 30 over 2, which is 15. Okay? The better way to do it, you're kind of reducing on the way there, is cross-canceling. Okay? So if I'm looking at these, I'm multiplying. I look diagonally to see if I can cross-cancel. So the 10 and the 2, I can take a 2 out of those, and that becomes a 5, and then we get right to the 15. Okay? We will have some fraction review coming here if you don't remember how to do that. Okay, so we'll take care of A together as a team here, then you'll pause the video and do B on your own and check your solutions when you come back. So A, we have distributive property going on in 2 places, all right? So distributive property here and distributive property here. This is the one where I'm going to see the most mistakes, okay? Because people forget to take that negative with it. So another middle school thing that kind of comes up to the high school is they teach you add a line, change a sign. So that way you can see that that negative goes with the number that's in front of the parentheses, okay? That helps you remember to distribute that negative with the 2. So we got 53 is equal to 3y minus 6 minus, so that would be, I guess, plus a negative 6y, but the negative takes over that, minus 6y plus 2, okay? Then you got to remember how you simplify things here. This would be the step where I do combining of like terms. So like terms would have the same numbers and variables, okay, and I should have underlined that negative with it, okay? If I put my y's together, I got a positive 3y and a negative 6y. That gets me a negative 3y, and then put my constants together. So negative 6 plus 2 is negative 4, okay? Now you don't need all the underlining and circles and stuff like that. I'm just doing that to give you a visual indicator of what we're doing, okay? And now again, just like the last thing, we're looking to get the variable by itself. So when you're solving equations, I know we've talked about this already. You do PEMDAS backwards. You do SADMAP, okay? You move things with addition, subtraction first, then you move things with division or multiplication next, then you look to get rid of exponents, and then you get rid of parentheses, okay? SADMAP is how you solve equations. PEMDAS is how you simplify expressions. So I'm going to add or subtract something first, which would be that 4, okay? So the 53 turns into a 57. And then we have negative 3y here, okay? And then we're going to divide the negative 3 because we got to do the multiplicative inverse, which would be times the negative third, but it's easier in your brain just to divide by negative 3, all right? And we get y is equal to negative 19, okay? And guess what? You can check your solution because you solved an equation with one variable, and you got one answer. So go ahead, work through B, and then come back, and I will have the work done on the video with the solution, and you can check it quick. Okay, so here's our worked out solution. You should have x equals negative 6. So step by step, I distributed, I added like terms, okay, and moved stuff around, and then I divided by that negative 4 to get x equals negative 6. Where might I see mistakes? Maybe here. People forgot to distribute that all the way through, or maybe people forgot to take the negative through, and you made a mistake there, okay? So those are the two places that you should check for mistakes on your work, okay? So solving equations, those are a few more steps than just one step, simple solving, okay? So here is where we kind of get to the most difficult point of the lesson, is solving equation literal, all right? This means that you're solving an equation for a specific variable, or you're rearranging a formula, okay? You have done this in physical science if you've taken physical science, or you will be doing this in physical science, okay? Generally, formulas are good for solving for one variable, but you can rearrange them using these tactics to solve for any one of the variables that are in the equation, okay? So we have surface area of a cone. I'm going to go ahead and rewrite that. So it's surface area equals pi RL plus pi r squared. We want to solve this for L. So you need to figure out in your equation where that variable is, and then ask yourself, how can I get it by itself? So again, you're doing SADMAP. All right, we're thinking about how to solve this. So all this stuff on the left here, what can I add or subtract first to work to get that variable by itself? I want to get rid of this. So minus pi r squared. That's just going to take that whole term and move it to the other side, okay? Then you could ask yourself again here, how do I combine like terms? Well, s is different than pi r squared, so we just have to write the two of them out. So my second step would look like this, okay? S minus pi r squared equals pi r l, okay? And again, we're looking to get the L by itself here. So now what do I need to move? What do I need to get rid of? I need to get rid of the pi and the r. So ask yourself, what operations are happening here? Pi times r times L. How do we undo multiplication? That would be division. So we want to divide both sides by pi r. And that'll get rid of it, leaving us with just L. Okay? So we would have L equals S minus pi r squared all over pi r. That's one way to write the answer, okay? If you wanted to spend a little bit more brain power on this question, simplifying it, you can think about how you simplify a numerator being added or subtracted with a common denominator. I can split this, putting pi r under both of them, all right? And so I'd have S over pi r minus pi r squared over pi r. And then I simplify it a little bit more, okay? I can't simplify this piece right here, but I can simplify this one. The pi's are going to go away, and one of the r's are going to go away. So your secondary answer will be L equals S over pi r minus r, okay? Either one of those are going to work. If I'm using this equation in some things and I wanted to rewrite the formula for L, that would be the better option, because that's going to be less things to plug in, less errors that I can make in a calculator, and it's actually a little bit simpler, even though it looks a little uglier maybe. Okay? So think about how you're solving for the variable you're looking for using reverse order of operations. Okay? Go ahead and try this one. So pause the video and then play the video, and your solution will be there. So we're looking to solve for W, which is right there. So I'm going to go ahead and rewrite this for us. And we're going to solve for that W. So what can I add or subtract to get the thing away from the term with the W? I'm going to get rid of that 2L. All right? P and 2L are different terms. So it'll be P minus 2L, or negative 2L plus P, however you want to write it, equals 2W. And then I need to get rid of the 2. So I'm going to divide both sides by 2. Or you can divide everything individually by 2 as well. Okay? So our final, or one of the final answers, maybe not the most simplest answer, would be this. Okay? That's one solution. I want you to get into a habit, if you have a common denominator, get into a habit of splitting that. Okay? I'm putting both of those over 2. So P over 2 minus 2L over 2, and you should see those cancel. So then you have W equals P over 2 minus L. This is the simplified version, and that's actually the better form of it. When we start graphing linear equations or changing things to mx plus b, we are going to want to do that process. Okay? So the second part of the lesson is solving inequalities, which is really similar to solving equations. There's only one extra rule on top of the other stuff. Okay? So this is where I'm highlighting this here. Don't forget what happens when you divide or multiply by a negative. Okay? And that is going to be these rules here, which look a little more complicated. But when you multiply or divide by a negative, you are going to flip that sign. Okay? That's the multiplication property and division property of inequalities. Simpler said, flip the sign. Okay? So looking at this one, 4y minus 3 is less than 5y plus 2. It points to the left, that is less than, okay? You might be getting some middle school tendencies in your brain. Just follow the arrow. Left is less than, right is greater than, okay? And if you need to write that out, left, less than, right, greater than. All right? An extra thing that goes with this is if you have the line underneath there, okay, that changes it to less than or equal to or greater than or equal to. Okay, maybe give yourself some notes to remember that stuff. But the steps to solving are the same, okay? You got to get a variable on one side and a number on the other side. So I think most of the people I've worked with like to keep the variables positive. So we'll move the 4y to the right. Okay, and then we'll move the constant to the left. And that'll get rid of those. All right, so step 1, step 2, we got negative 5 less than y. Now, something like this, we're going to graph these as well, okay, where it says graph the solution set on a number line. So a lot of the times, your teacher tells you to follow the arrow. Well, if I have it written like this, and I follow the arrow, it's going to be wrong, okay? So the best way to write these is always with the variable on the left, because whenever you read it from the variable. So this says y is greater than negative 5. And then you're like, well, Henrik, you said that always to the right is greater than. Well, that's if you write it with the variable on the left. So just take the whole thing, flip-flop it around, and then you can follow your arrows, and you can read it how you're supposed to read it. Okay? That should be the way it's graphed. All right? Now, the other version of this, like I just mentioned, if it's greater than or equal to, if this has that equal to sign down there, that's got to be filled in. Okay? But since our solution didn't have that, it's an open circle. Okay? So we're going to do one more of these, and then we're going to look at some examples on the worksheet. Okay? So let's solve this one together here. So we can move the x's to the left. And then we get x minus 2 is less than 7. Move the constant to the right. Add it over. Okay? We're moving it to a different side, so we have to change the sign. And we get x is less than 9. Okay? So that would be a open circle at 9 and going to the left because it's less than. Okay? before we jump to the other examples, we didn't use the multiplying or dividing by a negative thing on either one of these examples, okay? So I'm going to go back to this one and show you the way that I would prefer to do it, because I think a lot of people are going to graph this wrong, okay? I see a lot of kids make the mistake where they're graphing that wrong. So to avoid that, you always move the variable to the left, okay? So my first step that I would prefer is taking that negative, or that 5y, and subtracting it to the left, okay? When I do that, I get a negative y minus 3 is less than 2. I'll add that 3 over, and I get negative y is less than 5, okay? You cannot have the negative there. So this is where you're either going to divide by a negative 1 or multiply by a negative 1, and that's going to trigger our rule of inequality, okay? So since we divided by that negative 1, we have to flip that sign. That needs to flip going to the right, and you have a negative 5. So then we can follow the arrow or follow the sign to get the correct answer, okay? So that concludes the lesson for solving equations, writing equations of words, and solving inequalities, okay? If you would like to, you can be done with the video and get the worksheet. On the video here, I'm going to take care of a couple questions on your worksheet. So you might want to continue playing the video and check out those 2 questions, or you can begin the worksheet, okay? So I'm going to continue the worksheet questions to solve those. So maybe you want to pause the video, get your worksheet, and then come back here and look at questions number 21 and 24. Okay, so 21 and 24 both include fractions, okay? I'm going to show you some tricks to get rid of the fractions, all right? So if you're solving for f, okay, which is right there, I know it's kind of fuzzy, you might think subtract this over and then multiply by 4. That's going to work, okay? But you might make some mistakes with fractions. A better way to do it would be to multiply out your fractions, okay? So you're looking here and asking yourself, what would be a common denominator if I got it here? So between 2 and 4, I would have to get a common denominator of 4. So you're going to use that number, and you're going to multiply everything by 4, or 4 over 1. Okay? So multiply this by 4 over 1, multiply this by 4 over 1, multiply this by 4 over 1. Okay? Remember I told you right at the beginning of the video, best way to multiply fractions is to cross cancel. So I'm going to cross cancel the 2 and the 4. That makes that a 2. So this term turns into 2d. Cross cancel the 4s. They're gone here. That's just an f. And there is no cross canceling with the 6, so I have to do 6 times 4, which is 24. And then I'm looking to get f by itself, which is here. So all I have to do is subtract the 2d over, and then I'm done. Okay, so f is equal to 24 minus 2d. All right. Now these ones are a little bit more difficult. You can't really check your answer. You just kind of have to go with your gut. Remember, PEMDAS backwards, aka SADMAP. So 24, we're going to tackle this a similar way. We're looking to solve for m. So the first thing that I would do, since there's an m here and an m here, you should probably try to get rid of fractions, because fractions are kind of a headache with this stuff. So what can we multiply everything by to get rid of this? Well, I can multiply it all by n, or n over 1, okay? So if I'm multiplying this first fraction by an n, it's going to cancel that out, and I'll be left with just an m, okay? Then this one should be 5 plus 5mn, okay? 2 different variables. I'm just going to put them together. And then back here should have 20n. Now here's the trick with this one. I can't put that and that together because they're not like terms. This has an mn and this has an m. Okay, those variables don't let me put those together. So I have to use some other method of solving or rearranging to get the m by itself. So think about, is there something that we've done in the past where we take an m from 2 things? Well, yeah, that's the greatest common factor. We're factoring. So take the m out, And that leaves us with 1 plus 5n equals 20n. And now we got the m by itself. How are we going to get rid of that? We're going to divide it out. So divide by 1 plus 5n. And that'll take care of that. And we have a final answer of 20n over 1 plus 5n. Okay? So these are two examples that are a little bit trickier than everything we've done so far. With 21, we will use this tactic a lot to get rid of fractions. Okay? And with 24, we won't use the greatest common factoring a lot yet, but it'll show up in some of the harder questions. Okay? So there's two harder examples for you. Maybe you want to make some notes on those, but that concludes the lesson. Thank you for watching, and let me know if you have any other questions.